Hey yeah, everybody, Joe here. I want to check a puzzle today by Odd von de Wetering. It is called Miracle of 11. And normal Sudoku rules apply here. That is 1 to 9 in every row, column, and 3 by 3 box. Orthogonal neighbors, i.e. cells sharing an edge, are never consecutive. In the positive diagonals, i.e. diagonal sloping from southwest to northeast, the sum of neighbors is at most 11. Right. And that is all of the rules. So, if we start with these 8s, this can be 1 or 2, and this can be 1, 2, or 3. Is it gonna kind of do a German whisper type thing? Maybe. But this could have quite a few here. Well, it can't be 9 though. Oh, wherever 9 does go. What about 3? Is there more on 3? This is already kind of feeling bizarre. But a 4. Orthogonal neighbors are never consecutive. So the 9 can't go here. So none of these are 9, and the 9 can't go here because it would make 12. So the 9 is in one of these. This would have to be a 1. If this was 9, this would have to be a 1 or a 2. It would have to be a 1. Because 2 is consecutive with 3. So if that was a 9, that would have to be 1. This could be a 1 or a 2 though. That would give us a 1-2 pair for that row. One of these is 9 though. If this one is 9, then that is a 1. And that is a 2. And that would also be a 1 or a 2. What about 7? 7 could go there though. Oh, I was saying if this is a 9, then that is a 1 or a 2. But that can't work, because these would be consecutive. As it would be unable to be a 3, so this cannot be a 9. And this one is a 9. And now this is a 1 or a 2, and it can't be a 2, so it's a 1. And now... if this was 7... this can't be 7 either. Because this would be a 2 or a 4. And none of these can be 7. Because they are consecutive with 8. So 7 must go there. Now, this can be 1, 2, 3, or 4. But 6 cannot go there. So 6 is in one of those. This is a 1 or a 2, which does give us the 1, 2 for that row. So these two cannot be a 4. So the 4 is down here. Taking 4 out of there. Is that going to put a 5 here? Maybe not. Maybe not necessarily. But these cannot be 2. But that one can be. What if it was down here? I guess that would probably be okay also. So this cannot be a 2. Well, it can't be a 1 either, can it? Because if this was a 2, that would be 1. If this was a 1, that would be 2. So neither one of those will work. So this has to be 3. And now 3 will be over here. And this can now not be a 2. Because it is consecutive with 3. So we get that. This cannot be a 4 now. So this one must be, which will give me the 6. And the 5, I think, can go in either spot. Okay. What's left though is just a 5 and a, oh, and a 1. So that will sort that out. This cannot be a 2, so it must be a 3. 1 will be over here. Two must be in this little L. A 9 cannot go there. 9 could go here, I guess, maybe. Oh, what about diagonally? This can be a 2, 3, 4, or 5. It's quite a lot. It's gonna be a 3 in this little corner. A 1 is up here. Sudoku sounds good. Maybe that's all the Sudoku at the moment, though. Okay. Two. 2 cannot go here, cannot go there. It cannot go there. If 2 goes here, it must go there. Would maybe be okay. All of these are gonna... Oh, well, no, they don't necessarily have to alternate. The diagonals can add up to a very tiny number. They just can't exceed 11. So I'm only going to get help from the high numbers that I get. And I'm about out of high numbers in that regard. How about 7? 7 cannot go there. What about this? This can be 4, 5, or... This is 4 or 5 only. It cannot be 2, it cannot be 3. 4 or 5. Oh, it could be 7 as well. It is 4, 5, or 7 though. This one was 2, 3, 4, or 5. This one cannot be 3. It cannot be... It could be 4. It could be 6. 4 or 6 only. And what about this one? It cannot be 1, 2, or 3. It can be 4, 6, 7. Cannot be 7. So it is 4 or 6 only as well. Oh, but it cannot be 4. Because of the 3. Just to make sure. Cannot be 1, cannot be 2, cannot be 3. Cannot be 4, cannot be 5. Cannot be 7, 8, or 9. So this is 6. That makes 10. This could still be 4. If this was 4, though, this one would have to be 3. But let's go this way. This one cannot be 2. Can be 4. No. It can be 5. That's only 5. It can't be 2, it can't be 4. So it's 5 or 8, but 8 would be too high, so it is 5. Now 5 is up here, which would work here with the 1. There's a 6 up here. This cannot be 4 down here. And a 4 cannot be there because of the 5. So 4 is there. Now a 4 will be over here. And what about 2? 2 could still go here. What number cannot go here? This is going to be a 2 or an 8. What about this one? 1, 2. Cannot be 7. It can be 9. So a 7 goes in one of these. Is what that means. And a 7 goes up here. That's a lot of digits missing from here though, maybe. 1, 2. Can be 3. Cannot be 5. Cannot be 7. It could be 8. It cannot be 9. Okay. Maybe down here. This can be 2. Oh, is that all it can be? No, it can be 5. It can also be 6. 2, 5, or 6. Okay. Was this 4 or 6 only? No, it can be... Oh, maybe. It can't be 2. It could be 3. Oh, no, it can't. I think that is 4 or 6 only. Yeah. So this one, the highest it could be is 7. So that is 2 or 7. Only. This one would be 279 as well, obviously. Would probably be okay. Oh, a 2 cannot go here though. That is the point. And it cannot be 3, 4, 5, 6, 7, or 9, but this was 4 or 6 only. So this has to be 7, and this has to be 4. Now 7 this way cannot be 5. So that one is 5. 7 has to go with 1 or 3. Must be 3. Because 1 is at the bottom for that column. So this one will be 8. This cannot be 6 because of the 7. So that is 6. This is 9. And this will be 2. That is 11, which is fine. This is 11, which is fine. 8. This is 1 or 3 only. This is 2, 3, or 5. But I do have some down here. 2 and 8. Now this cannot be 1. 9 goes over here somewhere. Like that. Okay. This was 2, 3, or 5. I'll leave that, I think. This way, it cannot be 1, 2, or 3. It can be 4, 5, 7. This one, though, is only 4. Oh, that one is actually only 4. 1, 2, 3. Yes, it is. This can be 2, 6, 7, 9. Quite a lot. Four is up here. One is up here. 6 is down there. Oh, 6 cannot go here. Is that going to help? 6 cannot go here because this is 5 or 7. So 6 cannot be in this column. It cannot be in this column. So it must be in one of these, and it can't be there because of the 5. So that is 6. Oh, that was kind of tricky. I think I lucked into looking at that. 2 can be in neither one of these, cannot be in these, so it is in one of those. Can be either. Five cannot be. It could be here though. Finding one in the middle, like an 8 can't go here, but it's not gonna help me yet. Going horizontally, but that vertical one sure did. Okay, so... But a 2. Right. If I could find another one like that. What about a 4? A 4. Oh, never mind. I already got a 4 up there. If a 7 went there, that would be 5. How about this 5 going up this way? That could be a 1 though. 1 cannot be 2, cannot be 3, cannot be 4. Could be 5. And that is it. 1 or a 5. What about this 4 maybe? Cannot be 1, cannot be 2. Could be 3. Could be 5. Could be 6. Could be 7. Quite a lot. Five cannot be in this column. Can definitely be... Oh, 5 can't go here either. Actually, this is a 7 or a 9. So this cell can only be at a maximum of 4. Of course, if it's 9... Ah, this can't be 9, can it? If this was 9, this would be a 1, 2. And that would be 1. So they would be consecutive. So this must be 7. And that must be... still 1, 2, or 4. What about this one? If this was 9, this would have to be 2. That would have to be 4. That would be 6. That might be okay. What if this was 1 then? That would be 4. Oh, what did I just say? If this is 9, then this is a 2. and that is 4. If this is 1, then that has to be 4. Either way around, that is 4. Which gives me that 6. Which puts a 6 over here. It puts a 6 over here. This 6 maybe. And that could still be 2. Oh, this cannot be 2. 6. It can be 1. Cannot be 3. 4 or 5. 1, 4, or 5. That seems okay. Diagonal. This can go up to 7, 2, 5, 7. There cannot be, what did I say earlier? There cannot be a 5 here. There cannot be a 5 there now. There could still be a 5 in the bottom. Okay. 4. 4 is in one of these. It will go like such. 4 cannot go here. Cannot go there. It cannot go here. So it will go up here. And it will be diagonal of wherever the 3 is. That'll give me a 4 over here. Six is in this little cube. And this one. A 2 cannot be there. Two could be there though, I suppose. It could be in one of those as well, however. So in this row, we have 8 and 9 left. If a 2 went at the top, if a 2 went up here, I think it would have to be right here. Because we couldn't have 2 and 4 like this. Because one of them would be next to a 3. So if a 2 goes at the top, it has to go there. And then it would have to go there. Which would be fine for this diagonal. Is that going to break anything? It would need to be in one of those. That is okay, I think. So I don't think that'll get me quite there. Of course, a 2 could just as easily be down here and up here. What about a 3? A 3 cannot be in this one, and it can't be sitting next to a 4. So 3 is going to do just like it is over here, where it's going to be diagonal of the 4. 2 cannot be in the bottom now, so it must be in the top. So it will be in one of those, and now 2 will be in one of those. If it is here, that will be a 9. That will be a 1. That's probably okay. What is left here? What is left here? The maximum this can be is 8. Cannot be 1, 2, 3, 4. It can be 5 or 8. No, it can't be 5. Is this only 8? 1, 2, 3, 4 cannot be there because of the 5. 6, 8. 9 would be above 11 with the 3. This is 8 only. Now 8 is over here. Um, 8 again. The highest this can be is 1 or 3. Don't want to put that 1 there yet, I don't think. But with that 8 here now, that cannot be a 9. So 9 must be up here with the 2. Oh, and it can't be at the top. So that is that. And that will probably give me... Yeah, this was 5, 7, but it can't be 7 because of the 8. So that is 5. This is 7. This can only go up to 4. So it is... The only thing it can be is 4. So that'll give me a 4 there. This was 1 or 3. This cannot be 8. So 8 is there. And there. Oh, this cannot be 3. So this one is. Five. This can be... This is just 1, I think. It can only go up to 6. It can be 1, cannot be 2, cannot be 3, cannot be 4, cannot be... That is 1. This now can't be 2, so that is... 2 cannot go here, so it goes there. 2 is at the bottom. Alright, so this one now, it can go up to 8 as far as the diagonal. Now, with the 4, it can go up to 7. That still seems doable. Well, it is a 7, because it can't be a 9. So that is 7, that is 9. This cannot be a 6, because of the 7. So that one is... 9 would work here though. Oh, 9 must go here actually. And this will be with 5, which can't sit next to the 4. So it'll be that way around. 8 is over here, which will not work in the middle. So that row is like that. 1, 4, 8. These two get resolved. This can only be a 1 or a 2, so it must be a 2. And now... I know what all of these 3 are. A 5 goes either here or here. And the other number is a 6, I believe. And that will go in one of those. Okay. And the 3 numbers over here are 1, 3, 7. 1, 3, 7. Okay. I guess I could finish out these rows. There's a 1 over here with the 8. There is a 3, 6, and 9. The 3 must be over here, so that will be 9. And this will be a 2, 5, 7. 2 is over there. 5, 7. 5, 7. One of these has to be a 2. Well, that's already noted. Okay. There's 1 digit left here, which is a 9. And this will be a 5, 7. We could probably, right here, with this 9. It can't be paired with an 8. So that goes like that. Turns that into a 4, that a 1, that an 8, that a 4. 9 would work there, 9 would work there. Both of those work. This cannot be a 6 because of the 8. So it will be 3. Now this cannot be a 7. This cannot be a 7 either because of the 6. So we do make a pair and putting a 7 there. That will go that way. This cannot be a 7 because of the 8. So it'll do that. That's 11. That's good. That's 10. That's good. I think we're all right there. 5. Diagonally, did we get... I guess that stuff would still be okay. Still looks okay. At the moment. This only has 2 left, which is a 7 and 9. So this one must be 9. That one must be 7. I should know what these are. It is a 2, 5, no, 2, 6, 8. So that one is an 8. 2 and 6 are already in the row. And these will be, this can't be 6, so this one is. So that one is 2. Now this cannot be 3. So that gives me that. And it's just going to sort the rest out. That was an interesting little puzzle there. By Ad van de Wetering. I do hope I pronounced that correctly. Called Miracle of 11. Check it out yourself in the link below. Like and subscribe if you enjoyed. Thank you so much for watching and have a great day. Bye bye.